Welcome. So now we're going to be graphing the graphs of sine and cosine with transformations, which means we're going to have phase shifts and vertical shifts. All right, step one. So step one is so by the way, this is all in your notes, and everything except for the little starred part is already written down, including my handwriting. So step one is optional, factoring out b. It does make it so that you could look at the phase shift and know exactly what it was without having to solve. But I think for the amount of, if you're going to solve, you're going to factor out the b, you may as well just solve in the parentheses. So I'm not going to be factoring out b from any of our equations. It's not really a necessary step. Some students do like to factor it out, but it's not necessary. Step two, we're going to identify our key features: amplitude, which is the coefficient on sine or cosine; period, which is 2 pi divided by b; and number b is the coefficient on x, whether it could be factored out and be in front of the parentheses, or it could be on the x itself. It's still the same value. And if there's no coefficient in front of the parentheses or on the x, then b is 1 and the period's 2 pi. The phase shift, for the phase shift, we're going to set the parentheses equal to 0. If b has already been factored out, he's not in the parentheses anymore. So just what's in the parentheses gets set equal to 0 and solved. The vertical shift and midline is what's added or subtracted to the whole function, to outside the parentheses. All right, so once we've identified those 4 key features, we're going to find our 5 key points. It's the same key points as throughout the entire graphing section, right? So the x is the quad angle, 0, pi halves, pi, 3 pi halves, and 2 pi. And the y value depends on whether it's sine or cosine. If it's sine, then it's 0, 1, 0, negative 1, 0. If it's cosine, then it's 1, 0, negative 1, 0, 1. Right? It's just the values of sine and cosine at those angle measures. It's also the values of the x and y coordinates as we go around the unit circle on the coordinate plane. X is cosine and y is sine. So that's another way to think of it. All right, so we're going to transform our x values and transform our y values. Sometimes we'll have both transformations. We have 2 transformations that can be on x and 2 transformations that would be on y. The x transformations change the graph horizontally. Either it dilates, either stretches or compresses horizontally, or shifts it right and left and right. There are 2 transformations that could be on y. If we have an amplitude change, then there's a vertical stretch or compression, depending on whether it's greater than 1 or between 0 and 1. And then and also we might have a reflection as well. We'll take care of reflections and dilations, vertical reflections and dilations together. We're only going to see vertical reflections. And then the other transformation on y is vertical shifts, right? So x can have 2, y can have 2. Sometimes they have both, sometimes they have less. All right, so when we're finding our values, we're going to transform the x values by replacing them with the period divided by 4, starting at 0, and then counting by the period divided by 4. If there's a period change. If there's no period change, and obviously we wouldn't do that step, we're going to add the phase shift, add or subtract, depending on which way the graph is shifting, to the new x, to the period change values. If there's no period change, then you would just add or subtract from the old x values, the quad angles. All right, now y. So if there's an amplitude change, you're going to multiply the y values by the amplitude. And then if there's also a vertical change, you'll add or subtract, depending on whether it's up or down, to the amplitude changes. If there's a vertical shift without amplitude changes, then you would just add or subtract to the old y values instead. All right, if there's a vertical shift, then you're going to graph the midline, because it's a lot easier to graph on those vertical shifts if you can see the line you're oscillating about. And then we'll graph the function with the points, x, which is step 5, or y, which is step 7. Now, if there's not all of the different transformations to x, then it might be step 3, which is just the key points, or step 4, which is also the period change, right? So whichever step is the last step we did something to x, that will be our x value. The y value, if we have all of the transformations, the y value will be step 7, the vertical shift. If there is no vertical shift, then it would be step 6, the amplitude change, and if it's not either of those two things, then it would just be the original y values. Okay? So those are the steps. Let's go ahead and graph. We're going to go through all of our steps in graphing. So when you go to graph, now you know, you just do the same steps. This particular graph also has the parent graph there, y equals sine x. We're going to be graphing y equals sine x minus pi thirds. And let's first find all of our key features. All right, so amplitude is the coefficient on sine. There is no coefficient, so it is 1. And then period is 2 pi divided by b, but b is just 1 because there's no coefficient on x, so it's just 2 pi. For the phase shift, we'll set the parentheses equal to 0, so x minus pi thirds, oops, there we go, equals 0. Add pi thirds to both sides, x equals pi thirds. So this is pi thirds, this is a shift to the right. If there's no coefficient on x, it's been factored out, or there is none at all, you can look at the equation and know which way the graph is shifting, because remember, x minus is shifted to the right, x plus is really minus a negative, and it's shifted to the left. So if there's no b value on x, it's easier to figure out what the phase shift is. And then there is no vertical shift. Nothing is added. So let's fill in our values on our table, and then we'll graph. So x, and then there is no period change, so nothing in that column. Then we have a phase shift. We do have phase shift, so that happens to x. And then y, and then nothing happens to y. There's no amplitude change or vertical shift, so just cross that one out. Usually if I give you ones to, like, once we've done all of the different types of functions, so I give you one to graph, I'll give you a table that has all 6 columns, x, period, phase, y, amplitude, and vertical. You would just put an x through it if there just wasn't that type of transformation. So if I had 6 columns, I'd be putting an x through period, through amplitude change, and through vertical shift. All right, so the x values are always 0, pi halves, pi, 3 pi halves, and 2 pi. This is sine, so that'll be 0, 1, 0, negative 1, 0 is the y values. So now we're just going to add the phase shift to the old x values. So 0 plus pi thirds is pi thirds. For the others, we're going to have to get common denominators. So to be able to add. So if we want to add pi halves plus pi thirds, we have to find something that 2 and 3 are divisible by. By the way, consecutive numbers are only divisible by the product of the two numbers. So 2 and 3 are only divisible by 2 times 3. Or, excuse me, I should say that another way. The least common denominator, the common multiple for 2 and 3 is 6, their product. So we're going to change the pi halves to 6. Right? So 2 times 3 is 6. So we have to multiply the numerator by 3 as well. And then the pi thirds. So 3 times 2 is 6. So 2 times pi is 2 pi. So this is 5 pi 6. So the next phase shift number is 5 pi 6. So now we need to add pi plus pi thirds. So that is 3 pi thirds plus pi thirds is 4 pi thirds. And that would be 4 pi thirds here. And then we have 3 pi halves plus pi thirds. Again, we have to change. So 3 pi halves, again, the common denominator will be 6 because 2 and 3 divide evenly into 6. We'd have to multiply 2 by 3 to get 6. So we have to multiply the 3 pi by 3. So that would be 9 pi. And then, of course, we know that the pi thirds is 2 pi 6 because we just did that on the last problem, or the problem above. So that's going to be 11 pi 6. And then the last one, 2 pi plus pi thirds. Right, 2 pi would be 6 pi thirds. We have to change to, oh yeah, we just change it to thirds. We don't have to change, I don't have to change the pi thirds. Right, I only had to change the pi thirds if I was adding to a half. If I'm adding to pi or 2 pi, they can have a denominator of 3. Or at least common denominator would be 3. Well, we wouldn't change it to 6. So that's going to be 7 pi thirds. So 1/3 more than 2. 7 pi thirds. So now let's go ahead and graph the transformed graph. So this is our x is the phase shifts. And this is our y. It stays. So we have pi thirds 0. So we have to, I'm going to just put a little scale here. So there are 3 6 in 1/2. So you could just divide each of these lines into thirds because they're each a half. All right, that might make it easier for you to graph. So pi thirds, a third is 2 6. So that's going to go right here. And then 5 pi 6, 1. So just 1/6 away and then up here. And then we've got my shadows in the way, 4 pi thirds. All right, so that's going to be 2 6, and that's at 0. And then 11 pi 6, that, did I miss anybody? No. 11 pi 6, that would be 1/6 away, and that's going to be down at, what's the y value? -1. My shadow keeps blocking. And then 7 pi thirds, so we'll extend the line for 2 more thirds. That's going to go over here. So now we'll connect. And this is one period of the graph. Notice it has the exact same shape, depending on how well I draw it. if I miss any of my points. All right, so same shape and everything as y equals sine x. It's just shifted pi thirds to the right. Let's do domain and range. Domain is negative infinity to infinity. And this graph's going to keep going to the right and to the left in both directions. We didn't do anything to y, so negative 1 to 1. All right, and you can pause if you need to. And we're going to go on to the next graph. So I'm going to do all of the ones that just have a phase shift, no vertical shift in this one. All right, here's our next one. So we have y equals sine to the x, y equals sine x plus 3 pi fourths. So I think all of these ones are in notes. The amplitude is 1. Since b is also 1, the period is 2 pi. Phase shift. All right, so we have x plus 3 pi fourths equals 0. Subtract 3 pi fourths from both sides, so x equals negative 3 pi fourths. So that is to the left this time, not the right. So we're going to subtract. Actually, on the last one, did I put what we were doing? Any day now. No, I don't have a lot of space, but just as a reminder, I'll put on the rest of the columns, but we added pi thirds to get our phase shift. Here we're going to, all right, I'm done with this page now, move on. We're going to subtract. There's no vertical shift. So we have x, all we have is a phase shift. And nothing has happened to y. And remember, because since we're going to the left, we're going to subtract 3 pi fourths. So let's fill in the x values. So that would be 0 pi halves, pi, 3 pi halves, 2 pi. The y values that go with that for sine, 0, 1, 0, negative 1, 0. And then for the phase shift, we're subtracting 3 pi fourths. Again, we'll have to get some common denominators. But I'm sure we can do 0 minus 3 pi fourths, because that would just be negative 3 pi fourths. We're going to have to make everything into fourths. Actually, it's a little easier than the last one. We only have to change one number, not both. All right, so we have pi halves minus 3 pi fourths. We'll have to change the pi halves to fourths. So we'd have to multiply 2 by 2 to get 4. We have to multiply 2 in the numerator as well. And plus we know 2 fourths is 1 half. So we have 2 pi fourths minus 3 pi fourths. That's a negative pi fourths. So this is negative pi fourths. Pi minus 3 pi fourths. So you've got 4 pi fourths minus pi fourths. Minus, what was I finding? 2 pi 4. Wait, hold on. I forgot what we were doing. We're going 3 pi 4, sorry. Pi minus 3 pi fourths. So that would be 4 pi fourths minus 3 pi fourths, which is pi fourths. It's late, so I'm forgetting what I'm subtracting. All right, and so we'll write that in. That's pi fourths. And then we have 3 pi halves minus 3 pi fourths. We'll change the 3 halves to fourths. Just multiply numerator and denominator by 6. So that would be 6 pi fourths minus 3 pi fourths is 3 pi fourths. So we'll fill that in. And then 2 pi minus 3 pi fourths. So that's 8 pi fourths minus 3 pi fourths, so that's 5 pi fourths. So 5 pi fourths. All right, so this is our new x. Oops, but our y is still y. That's supposed to say new. And so we have the point negative 3 pi force 0. So that's going to be right here, halfway between, because each of these lines is a half. Negative pi fourths 1, so that'll be right here. And then pi fourths 0, that would be right here. So notice your graph, everything is evenly spaced. And then 3 pi fourths negative 1, so that's going to be over here, halfway between those two. And then 5 pi fourths 0. All right, so here is our graph. It's the exact same graph as y equals sine x, just shifted 3 pi fourths to the left. The domain is negative infinity to infinity. We didn't do anything to y, so the range is negative 1 to 1. There you go. If you need more time, you can pause, but I don't want to make this video too long, so I'm going to keep on going. I don't remember how many more graphs we have, but not that many more. Maybe 2. All right, here's the next one. All right, this one is a cosine. And we do have an amplitude change here. So amplitude is that coefficient on cosine. It's 3. Period, b is 1. So the period is 2 pi. The phase shift, all right, set the parentheses equal to 0, so x plus pi fourths equals 0. To solve for x, subtract pi fourths. And there's no vertical shift. All right, let's fill in our values here. So we have x. There is only a phase shift because the period's still 2 pi. Y, and then there is an amplitude change this time. So the x's are 0, pi halves, pi, 3 pi halves, 2 pi, just like always. The y values is cosine, so it's going to be 1, 0, negative 1, 0, 1. For the phase shift, we will add, oh, sorry, forgot, subtract. Pi fourths, because this is left. All right, so let's go ahead and do that. So 0 minus pi fourths is negative pi fourths. And pi fourths pi halves. So we're subtracting pi fourths from pi halves. Pi halves minus pi fourths. That would be 2 pi fourths minus pi fourths is pi fourths. And then pi minus pi fourths would be 4 pi fourths minus pi fourths, that's 3 pi fourths and then 3 pi halves minus pi fourths. All right, we'll change the 3 pi halves. That's going to be 6 pi fourths. So 6 pi fourths minus pi fourths is 5 pi fourths. And then 2 pi minus pi fourths. So that would be 8 pi fourths minus pi fourths. That would be 7 pi fourths. All right, and we've got our values there for x. Now we just need the values for y. We will just multiply by the amplitude, multiply by 3. So this will be 3, 0, negative 3, 0, 3. All right, so we'll go ahead and graph our points. So we have, so this is the new x, and this is the new y. So we're going to graph the point negative pi force 3, and then pi force 0, and 3 pi force negative 3. So notice how evenly spaced everything is, and that'll always be true. Then we have 5 pi force 0, and 7 pi force, so that would be right here in the middle, 7 pi force 3. And we'll go ahead and graph. Domain, negative infinity to infinity. The range this time we did do something. So negative 1 times the amplitude change, and 1 times the amplitude change. So that's going to be negative 3 to 3 is the range. And that's everything. All right, let's do the next one. All right, and this is the last one that we're going to graph in this video. If I'm not mistaken. Oh no, we have two more to graph. All right, let's do the next one. How are we on time? Ooh, 27 minutes. Let's see. I don't know if I want to make this 2 videos or not. Amplitude. Maybe I should. Well, let's see how long it takes us. Amplitude, I can always split it after I made it. Amplitude is the absolute value of negative 2, which is 2. But there's also a reflection, so we are going to multiply by negative 2. But the period technically is 2. I mean, excuse me, the amplitude technically is 2. Period, this time b is 3, so that would be 2 pi divided by, divided by 3, that would be 2 pi thirds. The phase shift, set the whole parentheses equal to 0 and solve, would be 3x plus pi equals 0, so subtract pi. 3x equals negative pi, and then divide by 3x is negative pi thirds. So that's the phase shift. And there's no vertical shift. So I have x. There is a period change that goes first. Then there is a phase shift. And then y, and there's the amplitude change. So x would be 0, pi halves, pi, 3 pi halves, and 2 pi. This is cosine, so that would be 1, 0, negative 1, 0, 1. For the period, we need to take the period and divide by 4. So the period values are 2 pi thirds divided by 4. Dividing by a fraction is the same as multiplying by the reciprocal. All right, so we could reduce the 2 and the 4. So that gives us pi 6. So we're going to count by pi 6. So we start at 0 and then count by pi 6. So 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6. All right, so that's useful because sometimes we're going to need a common denominator. Now we have them. But we could also reduce some of these. This one is the same as pi thirds. This one is the same as pi halves. And this is 2 pi thirds, which is good because we have the right period. All right, now for the phase shift, we're going to subtract pi thirds. So 0 minus pi thirds is negative pi thirds. All right, pi 6 minus pi thirds. So either we can just subtract or we have to change it to 6. So I'm just going to put up here that, I spit my lip, that pi thirds equals 2 pi 6. All right, so that means that pi 6, and we are moving to the left, so we're going to subtract pi thirds. Pi 6 minus 2 pi 6, because we already said pi thirds is 2 pi 6. So pi 6 minus 2 pi 6 is negative pi 6. So it should be a negative pi 6. All right, and then pi thirds. So pi thirds, and I don't have to use 6. I can go back to thirds because this works out nicely. Pi thirds minus pi thirds is 0. And then pi halves. So here we're going to have to get a common denominator. Let's get that common denominator, and because we don't have too much space there. So actually, we know what it is. Right next to is 3 pi 6. So 3 pi 6 minus, that would be 2 pi 6 for the pi thirds, is pi 6. So this one is pi 6. And then 2 pi thirds minus pi thirds is pi thirds. Oh, we'll write that in. All right, let's get the amplitude values and we can graph. So for the phase shift, we subtracted pi thirds. For the amplitude, we'll multiply by negative 2. Because we're going to take care of that amplitude and reflection all at once. So 1 times negative 2 is negative 2. 0 times anything is 0. Negative 1 times negative 2 is 2. And then this is 0. And 1 times negative 2 is negative 2. So there are the points. This is, the phase is the new x. And this is the new y. All right, so we're going to label this because there's no label on here. So choose something that works nice. We've got a lot of 6 here. What if we make each one, every 2 lines? So every line would be a 6. Every 2 lines would be a third. That way it won't be too crowded. All right, and actually I'll put one more. So, and this can go up by 1. All right, so we've got, let's see, negative pi thirds, negative 2. So that's, oh, somebody's mislabeled. Each line is a 6. That one is a third because it's 2 lines. And that's where I need to be. Negative pi thirds and negative 2 is right here. Obviously I don't want to see that, but hopefully you can. And then we have negative pi 6, 0. So that is right next because each line is a 6. And then, where is that? Pi 6. Sorry, who did I miss? Oh, 0, 0, 2. Sorry, I missed 0, 2 altogether. And then pi 6, 0. And then pi thirds, negative 2. All right, so all the points are evenly spaced. It's a very symmetric graph. So now if you've seen this graph, you should be able to identify that the amplitude is 2. Right, it increases by 2 in the numerator, in the positive and negative direction. You should be able to say the period went from negative pi thirds to pi thirds. That's 2 pi thirds, and it's shifted pi thirds to the left. All right, let's do the last one. And this one might be a little easier. So amplitude, coefficient on cosine is 3/2. The period is 2 pi divided by b is 2, so that's going to be pi. The phase shift, we have 2x minus pi equal to 0. We'll add pi to both sides. 2x equals pi, x equals pi halves. All right, so this is to the right. All right, so we have x, and then there is period change. And a phase shift. Then we have y, and there is an amplitude change. So we'll write down the usual x values: 0, pi halves, pi, 3 pi halves, and 2 pi. For the period values, you're going to take, where's our period is pi? Pi divided by 4. So pi fourths. So we start at 0 and then count pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, and then we could reduce. This one would reduce to pi halves. This one would reduce to just pi, and then matches the period. For the phase shift, we're going to add and subtract. Excuse me, add and subtract. We're going to add, because we're moving to the right, add pi halves. All right, so 0 plus pi halves is pi halves. And save a little space here, pi halves is equal to 2 pi fourths. So pi fourths plus 2 pi fourths equals 3 pi fourths. And pi halves plus pi halves, 2 pi halves means we have 1 pi. And then we're down to 3 pi fourths plus 2 pi fourths is 5 pi fourths. And then the last one is pi. So pi, 4 pi fourths plus 2 pi. Why am I? Oh, why did I make that? I don't need to make that fours. 2 pi halves plus pi halves is 3 pi halves. There we go. So I only needed to convert the pi to 2 pi halves so I could combine it with the pi halves. That's all I had to do. All right, so we've got all the values here. I didn't write them in. So now 3 pi fourths, pi, 5 pi fourths, and 3 pi halves. Probably should have filled in the y values first. The y values that go with those x values. This is cosine, so 1, 0, negative 1, 0, 1. But there is an amplitude change, so we're going to multiply by 3 over 2. So 1 times 3 halves will be 3 halves, and then 0, and then negative 3 halves, 0, and 3 halves. And then we'll go ahead and graph this. So this is the new x. This one is the new y. All right, so we'll graph pi half. Oh, let's label. So let's make, we've got some fourths. So let's make every other be pi halves so that every line can be pi fourths. So this is pi halves. That would make this pi, 3 pi halves, and 2 pi. All right, so we've got the first one would be pi halves, and 3.5. Oh, half. Oh, let's label one other thing. Let's just make this 1. 1, negative 1. All right, so pi halves, 3 halves. So that's going to be right here, and 1.5. So I'm going to use a different color. All right, and then the next one is 3 pi fourths, 0. So that'll be right here. And then pi negative 3 halves. So that'll be right there, 1.5. And then 5 pi fourths, which is going to be 1/4 over, and that one is 0. And then 7 pi fourths is going to be the 3 halves. And that would be there. And so here's our graph. All right, it's just that usual cosine, but shifted. First, it was stretched vertically, compressed horizontally, and shifted pi halves units to the right. The domain, negative infinity to infinity. The range, so we have negative 1 times 4. So, 3 halves to 1 times the amplitude change, 3 halves. So that's going to be negative 3 halves, 3 halves, and that needs brackets. And that's it for this video. See you on the next one. Bye for now.